In this example, we have two objects who both have some sort of initial velocity. So this changes our simplified or our shortened final velocity equations just a little bit. So again, these are all derived from your conservation of mass ideas, but we've just rearranged them so that we have an equation for v1 prime and an equation for v2 prime. So if we write out what we know, so that we have our gibbons listed, we have what we're going to call M1. So that's going to be Farmer Fred at 500 kilograms. He's got a V1 of 5 meters per second. And then we have M2, which is 1200 kilograms. And we have V2 at negative 25 meters per second. So of course it has to be negative here because it's going in the opposite direction. I'm defining moving to the right in my picture as positive and moving to the left as negative. So to go ahead and solve for Farmer Fred's final velocity, assuming this is a perfectly elastic collision, we have a simplified or just a rearranged formula that gives us direct access to v1 prime. So that is as such, v1 prime is equal to m1 minus m2 over mt times v1 plus 2 m2 over mt times v2. And again, you could derive this by making use of your conservation of momentum equations. So this is as simple as plugging everything in and solving. So m1, 500 kilograms minus 1200 kilograms divided by the total, which is 1700, times the first velocity, 5 meters per second, plus 2 times 1200 kilograms divided by 1700 kilograms, times the second velocity, negative 25 meters per second. So again, the negative sign is very important, just to denote that it's going in a different direction. After solving for all of that, what you end up with is negative 37.4 meters per second, which for us translates into 37.4 meters per second to the left. We're going to do a similar thing here to solve for the final velocity of the police car. So v2 prime is equal to, and in this case the equation is m2 minus m1 over mt times v2 plus 2m1 over mt v1. So by substituting in our values, we end up with 1200 kilograms minus 500 kilograms divided by 1700 kilograms times v2, which again, don't forget, is negative 25 meters per second plus 2 times 500 kilograms divided by 1700 kilograms, all times 5 meters per second. Plugging that into a calculator leaves us with negative 7.4 meters per second, which again we need to make use of the negative sign in a more useful way, which tells us 7.4 meters per second, and again to the left.